Okay, everybody, here's a practice test for test number 1. Basically, if you can work this practice test out, you should do reasonably well on the first test. This is no guarantee that everything on the test will appear here. This is solely for practice and to give you a feel for what to expect. Okay, so I suggest working a problem, stopping the video, working a problem, then play the video and check your answer, stopping it, working problems, playing it, checking, etc. Okay? You can't just watch a video, you have to do problems. Anyway, let's get started here. You will have several true-false type questions on the exam. These really rely upon you knowing and understanding the definitions. I'm not saying these are easy. Sometimes you just have to catch something in the statement that is just not right or just not said correctly. But anyway, the only thing here, you can practice, okay? But when you're trying to solve a true-false type question, you just have to be careful but when you read it and interpret the definitions. Anyway, A. Does this set here does this set, let me make sure my pen's working, does this set here contain 6 elements? Well, if you think about it, there's 1, 2, 3, 4, 5, 6 elements at C, but with the ellipses, what this means is that this pattern continues. So, some of the elements that are part of this set that you do not see, would be 6, 7, 8, and 9. So this set has 10 elements, so this is false. B, if the number of elements in A equals the number of elements in B, this statement is saying that A and B have to be equal sets. Alright, so 1, this notation here is saying how many elements are in the set. I don't know what's in A and B. I'm making the statement that the number of elements in the two sets are the same. Does that require A and B to be equal? And this statement is false. Why? Well, here's an example of two sets, that have the same number of elements. One element. But they are not equal sets. This one contains an A, that one does not. So they're not equal. So sometimes a simple example can help you confirm something is false. Oftentimes, it is harder to show something is true than false. Anyway, C. Alright. Now this is set builder notation. I don't normally include this on an exam, okay, but here it is. It's here. Anyway, X is a number in the natural numbers that is between 4 and 35. Is this an example of a set in roster notation? And this is false. And the reason why? This is actually set builder notation. Roster notation means you're going to list the elements in the set. So if I was using roster notation, I would be listing out all the elements in a set. So that's why this one's false. D. If we look at D, this symbol here means element. Okay, so that means element. So, is this item over here, the entire thing, that's important. When I'm talking element, whatever is over here better appear in the set over here. And if you look right here, it does. So this is a true statement. The set that contains the element 5 is an element of a set that contains a set whose contents is 5. Okay? One way this could trip you up, if we did something like this. So again, this one's true. But suppose you didn't have these curly braces here. And if it looked like this. If it looked like this, then this would not be an element. Because again, when you're talking element, whatever is over here, no matter what it looks like, has a look exactly the same on the right hand side. E, the set that consists of the 3 elements A, B, C has a total of 8 proper subsets. Alright, now this requires you to remember that a set has 2 to the n subsets, okay? where n is the number of elements. So this set has 2 to the third subsets, which is 8. But this one's talking proper. Proper means you're smaller. So one subset of this set here is the set itself, but it's not proper. So we have to take one of them away, and the number of proper subsets actually would be 7. So this is false. F, the notation here is intersection. If A and B is empty, then A and B are empty sets. Well, this statement here is saying A and B have nothing in common. That's what it's saying. A and B, what do they have in common? Nothing. Well, two sets don't have to be empty to have nothing in common. If you look at this example up here, take this to be A, take that to be B. They have nothing in common, so the intersection's empty. But they're not empty, so that one's false. Moving on. 2, 4, 6, 8. Is this a subset and a proper subset of 2, 4, 6, 8, 8? Well, it's a subset if everything here is contained here, and that's true. It's proper if it's smaller, and it is smaller. There's one element over here that's not over here, so that's true. H. Is cold equivalent to cool? That's not really what it's saying. What it's really saying, do these two sets have the same number of elements? That's what you mean by equivalent. Do these two sets have the same number of elements? And yes, they do. So yes, they are equivalent. Moving on, so again, you should be pausing the video as you go. Number 2. We want to determine the cardinality of our sets. The cardinality of a set is the number of elements in the set. Elements, when listed in roster notation, are separated by commas. So this set A has 1, 2, 3, 4, 5 elements. B, this set has 1, 2, 3 elements. That's all there is to that. For number 3, we have a set, consists of 1, 2, 3, 4, 5 things in it. We want to know the number of proper subsets of U. We also want to know the number of subsets of U. Well, we have a formula for the number of subsets. It's 2 to the n, where n is how many elements are in the set. So if I answer B first, I find out that we have 2 to the 4th, 1, 2, 3, 4, 5, 5. Got to count. 2 to the 5th, which you can show is 32. So now I have 32 subsets, okay? But to make something proper, you have to be smaller. Well, the only set I can't make smaller is the set itself. Every set is a subset of itself, but is not a proper subset of itself. So, again, if you want a proper subset, all you have to do is take away 1. And the answer to that is 31. Moving on. Number 4. A student has a choice of the following subjects. They can take English, math, biology, French, physics, drama, history, music. This is an exceptionally bright student who may take as many as 8 or as few as none. In other words, they don't care to go to school. How many options does he have in selecting subjects to take? Now, with this problem here, what you have to realize is that when you talk about the number of options he has to take in selecting a subjects to take this semester, he's picking a subset of this set of subjects, okay? So, when he goes to choose classes, okay, he's going to choose one of each of the following, or as few as none. So, we're talking subsets here. Since we have 1, 2, 3, 4, 5, 6, 7, 8, we have 8 possible elements. Cancel. Hold on, my thing's crashing every now and then. That happens. So I'm going to put it on pause. Okay, hopefully we can continue on here. But it happens, okay? Especially when you're using this type of recording software. Anyway, again, I have 2 to the n, which is 2 to the 8th number of subsets of this set here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So 2 to the 8th is my answer. And 2 to the 8th should be 256 if I'm correct, okay? So there's my answer. Moving on. Use the following Venn diagram, determine the following. Okay, when I use a Venn diagram, what's inside the Venn diagram are the actual elements in that particular region. So for question A, the elements which are not in B, okay, well let's highlight B. See, here's B. B is this entire circle, and we want everything not in B. So the two numbers not in B are 8 and 7. Since these are disjoint regions, I know I'm not going to overcount. So 8 plus 7 is 15. How many elements are in B but are not in A? Well, once again, everything in this circle is in B, but I don't want anything in A. So I have to take out whatever is in A. Well, if we erase this, sometimes it erases too much. And here's the stuff in B, not in A. So 4. Moving on. Number 6. We have the number of elements in the universal set is 200. The number of elements in A is 30 and B is 60. The number of elements in A and B is 20. How many elements are in A or B? Now there's two possible ways of doing this problem. The problem here is I do not know how many elements are in A or B, right? Right? So, I know a formula for this. It may or may not work. I might have to use a Venn diagram. So, what I'm going to do is try the formula. Number of elements in A plus the number of elements in B minus the number of elements in A and B. Hopefully I have all that information. I have the number of elements in A. I have the number of elements in B. I also have the number of elements in A and B. So the formula works. Very easy problem. 90 minus 20 is 70. Number 7. We're told 300 people watch a football or a basketball game. We also know 75 of them watch only basketball and 30 watch both. How many watch only football? Alright, so again, this is a counting problem. We know that 1, if we were counting how many subsets there were, we have the 2 to the n formula. If we were counting how many things are in one or another set, we have that formula we just worked with. Another way of counting would be to create a Venn diagram. So I'm going to create a Venn diagram here. It may or may not work. I'm working with 2 sets. One is football, one is basketball. Now, we know 75 people watch basketball only. So we know there's 75 people in this particular region. Remember, when we're filling in a Venn diagram, we're filling in a particular region. Regions are separated by the lines, right? So I'm not saying there's 75 people watching basketball. In this particular region, these are people watching only basketball. I'm also told 30 people watch both. Well, those 30 people have to be here. 300 people are watching football or basketball. So this is my universe 300. They watch football or basketball, so we know there's nobody out here because they're doing one or the other. When we add up all our numbers, notice we only have one region that's not accounted for. So if we take 300 and subtract from it 30 plus 75, which is 105, okay, we get 195. So the answer to this problem is 195. There's 195 people that only watch football. Again, I used a Venn diagram to count my way through this problem. Let's save this because I want to make sure at this point I don't lose what I've done. Okay? All right. Number 8. Bunch of set operations here, right? Okay? Here's my set. Universal set A, B, and C. A prime means what's not in A. So I'll go through the universal set looking for what's not in A. 1 is, 2 is not, 3 is, 4 is not, 5 is, 6 is not, 7 is, 8 is not, 9 is, 10 is not. So if I did that right, 2, 4, 6, 8, and 10 are not in A. 2, 4, 6, 8, and 10. Okay? This symbol here asks what's in common with B and C. Looking at B and C, what do they have in common? They don't have a 2 in common. They have a 4 in common. They don't have a 6 in common. They don't have an 8 in common. So if it's in common, it's got to be in B. 2 is not in C. 4 is. 6 is not. 8 is not. So only 4. Part of my curly braces. For the next one here, order of operations comes into play. I need to combine A and B together. So I'm going to do that first. I'm just going to throw A and B together. So 1, 3, 5, 7, 9. I'm not going to repeat stuff. Well, there's nothing to repeat because A and B have nothing in common. So when I look at it, I'm just going to throw B at the end. 2, 4, 6, 8. Now if you want to put them in order, you go ahead. Now I haven't taken the complement yet, so I'm going to have to be careful. Intersect with C. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Only thing missing here is 10. So the complement of this is 10. And I want to intersect this with C, meaning what's in common with C. I'll just put C in play here. And there's nothing in common, so that's an empty set. Now what's going to be hard here is for me to go back up here and find, alright, A union not in B. So I need A and what's not in B. So what's not in B? Alright, well, 1, 3, 5, 7, 9, and 10. If I get this right, 1, 3, 5, 7, 9, and 10. That's what is not in B, right? Sure. 1, 2, 3, 1, yeah, 1, 3, 5, 7, and 9, 10. Got it. I'll make sure here. Again, I don't want to mess up on the video, but if I do, you'll let me know, right? It doesn't, well, let's move on. All right, anyway. Okay, we need A. A consists of 1, 3, 5, 7, 9. So we're going to just throw these two sets together. So when we throw them together, 1, 3, 5, 7, 9. Now what's not in A, because again, we just throw them together. I already have the 1, I already have the 3, I already have the 5, the 7, and the 9. We just have to add in the 10. And then we have one more. A union B complement and C. The first step is doing the complement of B, so we'll just leave A alone. I think we had B complement right above us. That's convenient. 1, 3, 5, 7, 9, and 10. Intersect C. Well, we're going to join A union B complement together first. Well, guess what? We're lucky. We already have that up here. Remember, there's an order of operations, and that's what I'm doing here. So the previous problem is helping me out here. Now I need what's in common with C. So I'm going to grab C, 1, 4, 5, 7, 9. 1, 4, 5, 7, 9. What do they have in common? They have a 1 in common. They don't have a 4. They have a 5. They have a 7, and they have a 9. That's supposed to be a 9. Apologize for that. But anyway, there you go. That's what's in common. Okay, so again, when you have order of operations, I had to take B complement first. Well, it happened to be right here, the complement of B. And then I had to work left to right, A union B complement. Realized? That's what I have there. Then I have to intersect it with C. What's in common with this one here and this one here? Final answer. Now the last problem is I worked this out in class. Okay. So again, I'll just kind of mention a few things about this one. You always, when you work with a Venn diagram, the idea is to work with the disjoint regions. Okay. Meaning most of the numbers you find up here do not belong to a particular region in the Venn diagram. So the number has to be split up. For example, the people that like crawfish belong to this region here. But this region consists of 1, 2, 3, 4 disjoint regions. So before I can break the 10 people up, I need more information. I don't know how many people belong in any one of these particular regions. Because again, if you're in this circle, you like crawfish. All I know is there's 10 people somewhere in this circle. So the idea is you try to find one of the regions that you can fill in immediately. Well, I talked about this in class. We have 2 people that like our 3. If you like our 3, you are right there. 6 people like shrimp and trout. If you like shrimp and trout, you are in this region here. Let me might as well use a little color here. Shrimp and trout are in this region here. There's 6 people in that region. I've counted 2 people already. There's got to be 4 there. The total has to be 6. If 2 people are already in the region, then the total has to add up to 6. The 4 have to be there. 4 people like crawfish and trout. If you like crawfish and trout, you are in this slice right here. Likewise, there's a total of 4 people there. I've counted 2 people. There's got to be 2 people there. 3 people like crawfish and shrimp. If you like crawfish and shrimp, you are in this region here. Coming out like Mardi Gras here. There are 3 people in this region. I've counted 2. Got to be 1 there. Moving on. 15 like speckled trout. The world of the trout is this big circle here. In this trout world, there are 15 people. I have counted 8 people. 7 people have to be there. 10 people like shrimp and the crawfish. Okay. 10 people like shrimp. Might be running out of colors here. Okay, let's see. Let's see if we got this color here. I don't know. Yeah, let's get moving here. Okay, here's the shrimp world. There's 10 people there. I've counted 7 people. 2, 4, 6, 7. There's got to be 3 here. 10 people like crawfish. 10 people like crawfish. They're in this circle here. I have counted 5 already, so there's got to be 5 here. The only thing I haven't counted is how many people don't like any. There were a total of 24 people in my world. Of the 24 people, I have counted 5, 6, 9, 13, 20. I've counted 24 people. Everybody's liked something. Well, that's good. So there's 0 people here. The Venn diagram's filled in. I can start answering some questions. How many people like nothing? 0. How many people only like trout? If you only like trout, you have to be standing here. Explain that to yourself. If you only like trout, you have to be there. 7. How many like crawfish or shrimp? Crawfish or shrimp, you'd be in this slice right here. Let me maybe highlight. Shade it in. Crawfish or shrimp would be right here, right? 1 plus 2, 3. If you can read that. 3. There you go. I hope I did everything right. If it doesn't, that doesn't excuse you from the test, okay? Just let me know and I'll correct it. But there you go. Enjoy.